Hello everyone, I am Dr. S. Shashi Devi, Associate Professor of Physics, working in Vardhaman College of Engineering. So in this lecture, in this second video lecture of quantum mechanics, today we are going to discuss about Debroglie hypothesis. So what is exactly Debroglie hypothesis and what are its outcomes of this experiment? After the introduction of this black body radiation and photoelectric effect and quantum mechanics. So these three theories were not explained by the classical mechanics. Classical mechanics failed to explain these three theories: black body radiation, photoelectric effect and quantum effect. Quantum mechanics could able to successfully explain these three theories, as we have seen in the last video lecture. Now, after the introduction of this quantum mechanics, the next breakthrough in this particular field was done by the famous personality Debroglie. What is Debroglie's experiment and what is its outcome? Coming to classical mechanics understands that both the particle and wave are two different entities. And we know that a particle, we can find out a given particle by using some of the characteristics called mass, velocity and momentum and etc. It means by using these particular characteristics at a given point of time, I can measure where the particle is. At a given point of time, I can find out where exactly the particle is. Coming to a wave. Wave is not a physical quantity. As we know, wave is not a physical quantity. But whereas a particle is a physical quantity. So we can say at a given point of time where exactly a particle is. But coming to a wave we cannot say because it's not a physical quantity, it's a non-physical quantity, and but we can measure a wave by using some of its characteristics like wavelength, frequency and wave velocity are some of the entities by using which we can find out where exactly a wave is and what are its characteristics. So as far as the classical mechanics is concerned, so classical mechanics understands that both particle and wave are two different entities. We cannot combine a particle with a wave. Wave is a one different entity and particle is a different entity. Coming to quantum mechanics explains that both wave and particles are associated with each other. That is the wave-particle duality. So the wave-particle duality was introduced by the quantum mechanics and these particular waves are known as matter waves. So these matter waves were introduced by the quantum mechanics. What exactly matter waves are? Quantum mechanics understands that when a particle is at rest, no wave is associated with it. When the particles are accelerated with a high potential, these particular particles are moving like a wave and these waves are known as matter waves. And Debroglie was the person who invented these particular waves. So these names, the name of these particular waves also known as Debroglie's matter waves. So that is wave-particle duality. Here a particle is associated with a wave. It means when a particle is associated with a wave, the ambiguity also arises here. What is that ambiguity? When there is only a particle, I can find out where the particle is at a given point of time, where exactly the particle is. And if it is a wave, I cannot say where a wave is at a given point of time because it is not a physical quantity. Here in quantum mechanics, what is happening? So quantum mechanics understands that. So this particular particle is associated this particular wave. It means as there is no physical existence for the wave, even now it is impossible for us to find out the position of this particular particle because it is moving with a wave. So that's why here an ambiguity arises. And this ambiguity has been removed up to some extent by a famous personality known as Heisenberg uncertainty principle. Heisenberg uncertainty principle is up to some extent removed this ambiguity. That we'll discuss later. But here let us discuss about this Debroglie matter waves. So Debroglie, according to him, According to Debroglie, when a particles are accelerated with a high potential, they are moving like a wave, and these waves are known as the matter waves. And how could he is going to prove these waves? He didn't give any experimental proof for this particular one. By using simple mathematical equations, he explained these particular matter waves. By using simple mathematical equations, he explained these waves. And these waves are known as Debroglie's matter waves. What is its mathematical derivation and how we could able to prove that whenever the particles are accelerated with a high potential, how they are moving like a wave. He could not able to give the experimental proof for this matter waves. The mathematical part of the Debroglie's hypothesis. So according to Debroglie, when particles are accelerated, then those will be spread like a wave known as matter waves, and as well as these matter waves are also known as Debroglie's matter waves. These waves are known as Debroglie's matter waves. Now let us see the mathematical part of Debroglie's matter waves. How he could able to explain that whenever the particles are accelerated with a high potential, they are moving like a wave. Let us see the mathematical part of the Debroglie's hypothesis. Mathematical derivation of Debroglie's hypothesis. How he could able to explain that these particular particles are moving like a wave. For that, here I am going to consider two famous equations. One is Planck's theory, Planck's equation, and the other one is Einstein's mass energy relation. By using these two expressions, now we are going to show that how these particular particles are moving like a wave. In the last class, as we have seen, the Max Planck's famous energy equation is given by E is equals to h nu. Make it as an expression number 1. And Einstein's mass energy equation is given by E is equals to mc square. Make it as an expression number 2. Now, as equation 1 and 2 both are energy expressions, equating 1 with 2. I am going to equate equation 1 with 2 because both the expressions are the energy expressions. So I can equate both the equations. So with that equality, it comes out to be h nu is equals to mc square. Make it as an equation number 3. What is nu? Nu is the frequency which is given by c by lambda. Make it as an expression number 4. Substituting 4 in 3. With that substitution, it comes out to be hc by lambda is equals to mc square. Or else, the same can be written as lambda is equals to hc by mc square. So cc get cancelled out. So the remaining terms are lambda is equals to h by mc, which is nothing but lambda. Lambda is equals to h by mc. Here what is h? H is the Planck's constant and m is the mass of the particle and c is the velocity of the light. We are deriving this expression for the matter waves. So let us consider in place of c, I am going to consider it as an v, h by mv. What is v here? V is the velocity of the particle. V is the velocity of the particle because this lambda is associated with the matter waves. Okay, but not this light wave. So that is the reason in place of c, I am going to take it as an v. That is lambda is equals to h by mv. And let us make this mv as p and make it as an expression number. What is it? Expression number 5. Where p is equals to mv. Where p is equals to mv and which is nothing but the momentum of the matter. Now what is the final expression for lambda here? Lambda is equals to h by p. So what is this lambda here? So now here this lambda is associated with the matter waves. That is, this wavelength is matter waves wavelength. That is, this is the expression for the matter waves. Now where here p is the momentum and h is the Planck's constant and lambda is the wavelength of the matter waves. According to Debroglie, this expression for lambda is a perfectly general one. According to Debroglie, this expression for lambda is a perfectly general expression. General expression in the sense, so this lambda I can apply it to electron, proton, neutron, etc. To any of the particle I can apply this particular wavelength. To prove that this lambda is associated with any of the one tiny particle, let me take an example of the electron. I am going to apply this wavelength of an expression to electron, and our aim is to show that these particular particles are moving like a wave. For that, here I am going to do, let us apply the same expression for electrons. Let us apply the same expression for electron. As we know, in classical mechanics, already the kinetic energy and potential energy of an electron is already discussed there, and expressions were also given there. The same expressions I am borrowing it from classical mechanics. That is, the kinetic energy of an electron is given by half mv square. Okay, let me take this expression as 6 and let me take this expression as 7. And the potential energy of an electron is given by EV. Make it as an expression number 8. Here try to see the difference between these two V's, whereas this V is the potential and this V is the velocity. Try to differentiate between this. And we are applying this expression, Debroglie's expression, to electrons. I am doing it for the electrons. I am applying for the electrons. Now here both expressions are energy expressions. So I can equate equation 7 with the 8. So with this, it comes out to be half mv square is equals to E into V. Make it as an expression number 9. Multiplying on both sides of equation 9 with m. What I am going to do? I am just going to multiplying on both sides of equation 9 with m. So with that comes out to be half m square v square is equals to MEV. So make it as an expression number 10. But what is m square v square? We know that P is equals to MV. Just now we have derived this expression. So substituting P is equals to MV in equation 10. So on left hand side I have m square v square. So in place of m square v square, I am just going to add p square. That is half p square is equals to MEV. Or else the same can be expressed as p is equals to under root 2MEV. Make it as an expression number 11. Now substituting 11. So I have already derived here. So the general expression, let me consider the general expression, that is lambda is equals to h by p. We have already derived an expression for the lambda, which is a completely general one according to Debroglie. So this is equation 6. So in equation 6, I am going to substitute this value. Substitute 11 in equation 6. So with this substitution, the equation 6 is going to be modified as lambda is equals to h by under root 2MEV. Make it as an equation number 12. But what is here h? H is a Planck's constant whose value is given by 6.626 into 10 power minus 34 joule second, and m is the mass of the electron. M is the mass of the electron and is given by 9.1 into 10 to the power of minus 31 kgs, and E is the charge of the electron whose value is 1.6 into 10 power minus 19 coulombs. So in equation 12 we know the value of H, M and V, and where V is the potential, and I don't know the exact value of the potential. So how much with potential I am going to accelerate the electrons. So leaving this V, so I can calculate all the values in equation 12. That is lambda is equals to 6.626 into 10 power minus 34 by under root 2 into m value is 9.1 into 10 power minus 31 into the charge of the electron is 1.6 into 10 power minus 19, and root V is there. Just keep it aside. Now by substituting all these values and calculating this, so then lambda comes out to be 12.26 angstrom by root V. This total value. So this comes out to be, so this highlighted one. Just have a look. This highlighted value after calculation, so it comes out to be 12.26 angstrom. And root V is already there. So the same I am going to keep it here in the denominator. That is lambda is equals to 12.26 angstroms by root V. So this is the expression. But what is V here? V is the potential. So now I am going to accelerate these electrons with a high potential. So that is the reason Here I am going to take V as 100 volts. If I'll take V as 100 volts, so then what happens to lambda? Lambda is equals to 12.26 by 100. So then it comes out to be 1.22 angstroms. So this is also one of the famous expression. After substituting V as 100, so lambda comes out to be 1.22 angstroms. So what does it mean? What is the conclusion given by Debroglie? Now this wavelength is of electrons. This wavelength is the electrons wavelength. In those days, the one more waves were discovered, and those waves are nothing but X-rays. X-rays were accidentally discovered by a famous scientist known as Röntgen. Similarly, in that particular period only, X-rays were discovered by Röntgen, and Röntgen found the wavelength of these X-rays of around 1 angstrom. And we know that X-rays are waves, and wave nature of the X-rays were also proved by using some light phenomena like diffraction and interference. By using that phenomena, X-rays were discovered, and this particular X-rays were known as waves, wave nature, and whose the wavelength of the X-rays is around 1 angstrom. Then Debroglie assumed that if X-rays are behaving like a wave and having the wavelength 1 angstrom, maybe these electrons associated with a wave, that is, we are accelerated. So accelerated high potential waves of electrons, and we have found the wavelength of these electrons as matter waves as 1.22 angstrom. So which is nearly equals to the wavelength of X-rays. So this wavelength is nearly equals to the wavelength of X-rays. So by this conclusion, Debroglie assumed that whenever the electrons are accelerated with a high potential, they are moving like a wave, and those waves are known as the matter waves, and they are moving like a wave with a wavelength of 1.22 angstrom. So that's why he named the new types of waves have been introduced in the universe, and those waves are known as the matter waves. And whatever the work he did, for this particular work, even he got the Nobel Prize in 1927. But the thing is here he could not able to give the experimental proof for this. He could successfully able to explain the matter waves, and he could able to compare that with the X-rays, and he could mathematically, he said that the new types of waves have been discovered, and those waves are known as the Debroglies matter waves, and they are behaving like a wave. Everything is fine, but the experimental proof was not given by the Debroglie. He could not able to give the experimental proof. Until and unless no experimental proof is given, so no one is going to accept the new waves. So that experimental proof was given by the other scientists known as Davison and Germer and G.P. Thomson. That we'll discuss in the next class. But here the new waves have been discovered by the Debroglie, and those waves are known as the Debroglies matter waves. Thank you.